Hello everyone, welcome to the solution of LeetCode problem 2101 named Denote the Maximum Bombs. In this problem, we are given a list of bombs. The range of a bomb is defined as the area where its effect can be felt. And this area in the shape of a circle with the center as the location of the bomb. Now, the bombs are represented by the zero indexed two-dimensional array with three integers where xi and yi is the coordinate of x coordinate and y coordinate of the bomb, and r is the radius of the bomb or its range. You may assume to detonate a single bomb. When a bomb is detonated, it will detonate all other bombs lies in its range, and these bombs will further detonate the bombs that lie in their range. So we are given the list of bomb. Now we have to return the maximum number of bombs that can be detonated if you are allowed to detonate only one bomb. So here in this first example, let's understand it. The coordinates of the two bombs are 2, 1 and 6, 1. So the center of the first bomb is presented in the 2, 1 and the center of the second bomb is presented in the 3, 1. Sorry, 6, 1. And the first bomb radius is 3, second bomb radius is 4. Now, if at first we explore the first bomb, we can see that its green shape will not affect the center of the second bomb. So, if we explode the first bomb, only one bomb will explode, which is the first one. And the second bomb will not be affected. But if we explode the second bomb, we can see that the radius will touch the center of the first bomb. So here we can see that in total 2 bombs will be exploded. So we have to return 2. I hope you understood the problem statement. Now let's move on to the algorithm. Now here, to understand the algorithm, we have taken this example. This is the coordinate, and we are given in total 9 bombs. The center of the first bomb is this, and the center of the third bomb is this, and so on. Now, if we explore the bomb number 2, the bomb number 1, 3, and 4 lies in the range of bomb number 2. So in total, there will be 4 bombs will be exploded. Now, if we explore the bomb number 8 or bomb number 9, only one bomb will explode each time, because the center of the bomb number 8 does not belongs to the area of the bomb number 9 and vice versa. So there are only one possible damage. There is 4 possible damage. And here, if we explore the bomb number 6, we can see that only 2 of the bomb will explode, which is bomb number 6 and bomb number 7. So in total, the maximum will be 4. So it will be optimal for us to explode the bomb number 2 first. But how can we basically solve this problem? Let's think this problem like a graph, and each of the bomb is connected to another bomb, right? And if one bomb is connected to another bomb, that means if I explode this bomb will explode. If it is, that means the second bomb should be in the adjacency list of the first bomb. This is the main criteria. Now let's make the adjacency list of this example. Initially, we're at the bomb number 1. So here we can see that if we explode the bomb number 1, none of the other bomb will be affected. So the adjacency list will be empty. Now for the bomb number 2, we can see that the distance between these two center 1 and 2 which will be, let's say, x2 minus x1 whole square minus y2 minus y1 whole square. And if the radius of the first bomb is less than or equal to this distance, then we can say that the first bomb is connected to the second bomb, or the second bomb is connected to the first bomb. So here we can see that for the adjacency list of 2, it will have 1, 3, and 4. Because this is supporting this equation. Now for the adjacency list of 3, none of the element is present. For the adjacency list of 4, none of the element will be present. Now here, for the adjacency list of 8, none of the bomb will export, and for the adjacency list of 9, none of the bomb will export. But for the adjacency list of 5, we can see that none of the bomb will export. But for the adjacency list of 6, here we can see that if we explode the bomb 6, the bomb 7 will be affected. So 7 will be presented in the adjacency list of 6. And similarly, if we explode the bomb 7, the 6 will be affected. So here, we have seen that we have built the adjacency list by using the equation and the given graph or the given bomb location. Now, how can we basically determine what is the maximum number of bombs can be detonated? So here, initially, we have to run the DFS from each of the node and calculate the maximum number of node we can visit by starting the DFS from this respected node. Suppose we started the DFS from 2. So here one of the cell is visited, which is 2. Now from 2 there is 1. So cell 1 will be visited. From 2 there is another cell which is 3. So the cell 3 will be visited. And from 2 there is another cell which is 4. So the 4 will be visited. So we can see that if we start the DFS from the cell equal to 2, in total there will be 4 cell can be visited. But if we start the DFS from the node 6, then from the node 6, it has a variable or the element 7. So 7 will be visited. And for the node 7, we can see that the node 6 will be visited. So in total, there are 2 nodes can be visited, or the 2 bombs can be explored. So this is the algorithm. For each of the cell, we have to run a DFS and calculate the number of visited cell we can get. And the output will be the maximum of the number of visited cell. Now let's wrap up the algorithm. As we are given some of the coordinates of the bomb, we will make the adjacency list by using the coordinates and utilizing the Euclidean distance formula. Now for each of the bomb, we will start the DFS and count the maximum number of cell we can visit. And here finally, we have to return the maximum number of cell we can visit. So this is the algorithm, and overall time complexity of this algorithm is big O of n, where n is the number of nodes or the number of bomb. I hope you understood the algorithm. Now let's move on to the code. In this problem, the code is pretty simple. At first, we are given a function named maximum donation, which has a two-dimensional grid as bomb, and we are taking our adjacency list and Boolean vector initialized with false. Now, for each of the entry in the bombs, by using these two loops, we are calculating the Euclidean distance, which is x2 minus x1 whole square plus y2 minus y1 whole square. And if this distance is less than or equal to radius square, that means it can be possible that if we explode the bomb I, the bomb j will also be explored. So adjacency list of I, pushback j. Now inside the DFS for each of the cell, we have to determine how many numbers of cell we can visit. Initially, we have to call the DFS function into the corresponding cell, and in the DFS function we have to make the node true, and for each of the child in the adjacency list, if the child is not visited, we have to recursively call the DFS function for the child. Now, after completion of the DFS function, we have to check how many numbers of node we still visited. So for each of the cell j, if the current visited of j is true, we have to increment the counter and upgrade the answer will be maximum of answer and counter. Now for the next DFS, we have to reset the value of the visited vector. So we have to initialize the false value for all of the visited vector. Finally, we have to return answer, which is the maximum number of bomb it can explode. I hope you understood the code. Thank you everyone for watching the video. We will get back soon with another LeetCode solution.